Welcome to another CO2 Monday in the Refrigeration Mentor podcast. I'm your host, Troy Matthews, and today we have a really cool event. A good friend of mine who actually trained me a bunch on CO2 so far over the last couple of years. I'm still learning every day from this guy, but my friend Mads Jensen coming to you from the Advansor CO2 Training Center in Denmark. I'm super excited about this because I've seen lots of videos from this training center, lots of YouTube videos, but not actually have a live training. So I'm super excited to have this conversation, really share with what Advansor has going on because they have so much going on over the last few years. And as CO2 continues to grow, I see their teams continuing to grow, and plus their training growing. One of the top trainings, CO2 trainings I've been attending and part of, which I'm super excited. Mads, welcome to CO2 Mondays. How you doing?
I'm doing very fine, thank you.
Why don't you do an introduction about your role at Advansor and what you do?
Well, actually, I work as an after-sales engineer. We have different kind of tasks. I'm doing commissioning, hired to do commissioning, and we also maintain the service mail where we actually handle service call, different kinds of service tasks, warranty claims, etc., etc. I'm actually also the one who is responsible for our trainings here at Advansor. Some of the things I'm doing here is, of course, we have these 2 days trainings. We're going to talk a little more about today, I guess. Then we also have the online trainings, which you're participated in. All these trainings, something we have developed just to share the knowledge and broaden the knowledge regarding CO2 and, of course, our RECs that we produce at Advansor.
Because I continue to hear more and more about Advancer. Like, do you know how many racks that you guys are putting out per year now? Because I know it's been growing year over year. You have over
Yeah,
250, I believe, on your team, plus 250 staff at the team. So, how many CO2 racks are you guys producing?
we are producing close to 2,000 RECs per year.
Wow.
Yeah,
Awesome. I love to hear that.
it
That
is.
number is going
It
to
is.
just double each year. You're going to see it just continue to grow, which I love.
That's at least our aim.
Yeah.
So
Yeah,
yeah, it is.
you won't have a problem. So you do a lot of the commissioning, the startup, but one of your big focus is training, and that's really how
Yeah,
we met. You're doing a lot of online training, in-person training. Let's talk a little
yeah.
bit about that before we dive into we're going to see today at your
Yes.
training facility and what you do. So let's talk a little bit about first the online training, what that's about, because I know on January 17 you start another rollout of 12
Yes.
series modules, which I'm excited to be a part of again.
Yeah, well, the online training to start with was something we developed with all this Corona crisis. We had a couple of years ago. We were starting to look into how can we actually reach out to people, and that was actually where we started to develop this idea with doing some online trainings, where our main focus here is to look at the technical part of a CO2 transcritical system. Of course, it is the advanced CO2 transcritical system. It was very important for us to try to reach out to and demystify the things with the CO2 as a natural refrigerant. And this was one of the, I actually think it's a very good way to do it. And we have it in 6 different languages today. So 7 actually. We also have a Swedish one. So it is very, very cool.
Yeah, no, and that's what's pretty cool. Like you're doing this training in a ton of different languages, and like I said, I was glad to be a part because I learned so much just from those online portions from you. What about the 2 days? So we're also going to get into a 2 day training, and this is kind of what we're going to see today. Some of the stuff that people who go out to Advance and go into their in person or hands on training, what they're going to get. So what's all involved in a 2 day training?
Well, a 2-day training is, you have been attending to some of my technical trainings online, and you know I use a lot of time. Each module, I always cover our PIDs
Yeah.
just to go with the flow of the refrigerant cycle in the rack. I actually do the same here when we have these trainings on 2 days, some of the things I do is I take the PID, I walk through everything we have on the rack from the MT compressors and all the way explaining the discharge side, how the high pressure valve is functioning, the receiver, its role in the transcritical CO2 system. Of course, we also talk about the consumers, that is the receivers we have, cabinets, etc., superheat, everything. And it's just so easy to take the PID and walk through very slowly and have this dialogue when you're doing it, and at the same time show what I show on the PID. I can at the same time actually show that directly in our rack.
Yeah.
So that's pretty cool.
No, and I love that because that's how I do all my trainings now too, is because it's so important to understand that piece of equipment that you have firsthand. It doesn't matter if it's a rack or if it's a package unit, whatever system it is, you need to know where everything is going, what component is
Yeah,
where, what way is flowing. And then when you understand that and how each component works, man, it makes your troubleshooting life so much easier.
it does. It does. I totally agree. And that is actually what we have to spend a lot of time on, because I think one of the things that is special with the CO2 racks is the pressure we're working in.
Yeah, no, but you're
Perfect.
totally right. That's one of the
Yeah.
biggest things when I'm doing my CO2 trainings as well, is just getting the technicians or the people, engineers, it doesn't really matter who it is, just wrap their head around about the pressure.
Mm.
Pressures we need to be concerned about, but the way systems are designed today, especially the way like Advansor designs them, there's so many, we learned so much over the last 10, 15 years that there's so many proper safeties in there, proper shutdown procedures, really the steps that we didn't have 15, 20 years ago, we have now. So having, it doesn't matter if it's running at 700 psi or 1500 psi, or 80 bar,
Yeah.
1160
Yeah.
psi. It's it's designed very safe CO2 systems today.
Yep, I totally agree with you. And that is one of the things what we actually use a lot of time when we do this technical trainings. It is all about demystify with the pressure, with the temperatures, everything like that, and just actually explaining how similar a lot of the things are to a lot of other refrigerant types and everything like that. It's not, yeah, it's higher pressure, but it is actually the way you service it, the way you handle it is the same. The amount of safety features we have on our racks today is amazing. It is just so numerous because we had to put everything into consideration when we design these racks. And to be honest, it is no more different comparing to a lot of other refrigerants. So
Yeah. If it's not, higher pressures, and now there's mildly flammable and flammable refrigerants. So it doesn't matter really what part of the industry you're in, if it's CO2 or not, there is still, you have to be safe in refrigeration. There's electrical, there's pressures, there's chemicals, right? So it's what you really need to respect it.
yeah,
I really don't think the pressure is an issue. You know what I mean? Now that I've been involved in it, and I see how many people, I think it's a kind of a mindset thing because, well, we're working at 200 psi, and then you go to 410A, now it's 400 psi. Now, okay, now we're at 1,000 or 1,200 psi. Yes, it's higher pressure, we need to respect it, but when you understand the processes and the procedures that you're when you're working on this equipment, because you need to be trained, you need to be
yeah,
trained on this equipment. You can't just go in and just say, oh, I'm going to start working on it. It's like any refrigeration system, you need to be trained. Going, this is a highly skilled profession, refrigeration. So it's something that you should be trained on first. And then when you do get that training, you go to Advansor training and you understand where to start, where to go forward, and and all those procedures, it makes it so much easier.
I totally agree. And that is also the things we try to when we do this training is just to teach people, educate people how to treat CO2 as a refrigerant, demystify it. When can it be dry ice, and how can you take the pressure out and put the pressure into a system after you have been working on it? Pump down, the basics. There are slightly more valves on a CO2 rack, but you just need to get an overview and see when I have to perform this kind of service, what can I do? And that is actually, as I see it, one of the most important things here is to learn people how does it work, what is the difference between other refrigerant types, rack with the systems and CO2 rack, and how do we handle it very easy. You see, at the moment, I'm standing in a rack with set point here, even though it's standing still and not running. It is, I think it is close to 800 or 900 psi at the moment, and nothing happens, you know.
Yeah, when it's designed for that pressure, then you don't have to
Exactly.
worry about that. And this is what you
No.
work about with the manufacturer and your end user and your customer. But the big thing is just understand the piece of equipment you're working on. Why don't we
Yeah.
dive into actually checking out and showing everyone kind of what your training center looks like, as well as let's go through some of the your
Yeah.
CO2 rack that you guys have there, that you teach and educate people on about the safeties, about the procedures, about the pump downs, because all that stuff's important. And I've seen this time and time again where I've talked with technicians and they're like, Trevor, well, it's so much different. But at the end of the day, everything downstream of that high pressure valve is the same as any other refrigerant. You know, you got your subcritical systems. You know, you go to your
Yeah.
evaporator. Well, how do I pump down an evaporator? Well, it's pretty much the same thing as you're doing on your HFC racks that you're working on now. A lot of the procedures are exactly, well, how do I pump it down? What do I need to look for? Well, there's a few things you need to watch out for, but I've done so many CO2 trainings now. And then I asked the technician, well, how do you pump it down? And they explain it. I'm like, how is any different than an HFC? Well, now that I think of it, it's not really any different. I got to watch the pressure in my tank. I got to see the if the receiver level is getting too high or the flash. So it's all the same things, but it's just like it is a bit different. There's a few things you want to look for, but in the end, they're like, wow, it is very similar.
Yeah. I totally agree. If you look at this, this
Nice.
is actually our training facility. We have room for 20 people here at once.
What a beautiful space. A lot of open area there. That looks great.
Yes, we are really working with different kind of controller and surveillance platforms, system managers, etc., etc. Up here, you can see we have our different kind of rack. It is easy for me when we do this. I can also cover the range in between where we go to other rack platforms, but still, we when we look at our PRDs, etc., they're kind of similar all the way through. You have actually used some of the different PRDs at the moment when I do my online technical trainings, so you have seen them.
Yeah.
But let's just have a look. As you can see, we have a nice open compressor cut up from pizza. What we see here is at the same time different valves on the shelf. You can see we have an example of a different low pressure lift and the Danfoss ejector at the same time in here.
Yeah.
Also the receiver with a suction accumulator in the receiver, and in the bottom of the receiver we have this heat exchanger as well. So cut open so we can follow the pipes. This receiver is from what we call our value pack 2.
Nice.
Very cool design.
Yeah, that's so important. That PID is. Some of you may have seen these before. It's up on the screen there. Some of you may not. And those that are listening to, look up, research PID, what it is, piping and instrument drawing. They are so important on any piece of equipment that you're working on, and they will help you in so many different ways, especially in the technical side. I say this time and time again. If you don't know all the components in your system, you're kind of troubleshooting blindly.
Exactly. This is 3 example of oil separators that we use in our different kind of platforms. The hermetic one is cut up, and the one in the middle is actually what we use is a type with a hermetic one, but that is because we have the ability to show how it's actually designed inside. And then, of course, the well-known temperate oil separator we also have here.
Yeah, and once again, so
Yeah,
Advansor, they design the equipment from different manufacturers. So they purchase a lot of different equipment. So you got to remember that you also need to go in and learn about that manufacturer's component as well. So if it's Danfoss, if it's Temprite or whoever, it's real important to find those spec sheets as well. I know you guys provide them with your equipment in your books and in your electronic documents, but I really think that's important for people to know that yes, you work on this manufacturer's equipment, but that each component's from a different manufacturer potentially. So you got to learn about those.
It is also a part of our philosophy, the way we have chosen to design our rack, is that we take stock things like compressors directly from bits of which you can go to a lot of different places and get new ones. We have the same with all our cables, everything, valves, etc., etc. Everything is from known manufacturers, which we assemble here and make one unit. That should make it easier to maintain our rack in the rest of the world. No matter where you go in the world, it is pretty easy to get a replacement item.
Yeah.
So that is very important when we have that. That is, yeah, part of the design philosophy we have.
And what I've really liked about, I've been, like I said, lots of your trainings, your PIDs are really similar. So if you're looking at a different size of equipment, or if you're looking at a different piece of equipment, or even a PID drawing of a larger system, all you guys set up all the valves similar, like with
Yeah.
similar names, similar drawings. So it's like when I see a different one, it's like I already know this piece of equipment, which is real cool when you're doing those designs.
We have these different platforms, and in most of our platforms, we have the same place where we place our gas bypass valve, our high pressure valve, the receiver, etc., etc. We have made some differences on some of our new platforms, but the philosophy is basically the same. So it should, no matter what kind of rack you actually come out to, it is similar to other racks from Advansor. And especially when you compare to how we designed the PID, those go very well together. That is at least our aim.
Yeah.
I will actually also show you one example here in the back, because as I mentioned before, one of the things we are trying to do here is to have different controller platforms. And we are actually able to run the rack with the, in our training room at the moment, it is 4 different controller platforms that we can run with this rack. Very, very cool.
And
Let me
which ones
just
are
have,
they? So you could do a Danfoss, I know you
yeah.
mentioned. You can do Corel. What other ones?
Yes, here we have the Danfoss controller. Then I can also choose German brand Wurm. We can run with that as well. Then, of course, I have the Carel. We can also use this one. And here in the end, here we have a Egelman controller.
Nice.
This is 4 different controller platforms that our rack is actually supporting.
And so this is great
The,
for if you're a contractor and you're working on one of these, you can come and learn about that specific controller, which makes it
yes,
so much more specialized and customized for that
yes.
specific customer.
Exactly. And it also, as I mentioned, let's just take this German example here. A lot of the German contractors and the shops, the racks are delivered with the Wurm controller. It is, you can call it kind of local for the German-speaking areas. It is a very good controller platform. And with our German trainer, that is the one they're using when they want to perform some kind of training here in the training room. If we have some other, then we can use, for example, the Danfoss controller. And it is mind-blowing simple just to change between each controller platform. You can see here we have different evaporators, users, and I can just turn it on and turn it off again. The same I can do with the controller platform when I want to switch between those.
Okay, and
So
then you
that is,
even have RDM as well, control on, so you
yeah,
got even
I have
another
RDM as well. Yeah.
lots of
That
there.
is the one we have here.
Awesome.
So yeah, every time we come here, it is very cool.
I noticed just
Yeah.
looking at from the picture, I see you got drives on there plus compressors with capacity controls. Like,
Yes.
so you want to talk a little bit about the different technologies you have on this track to train contractors that come in?
I can actually do that. As you might see here, we have 2 different inverter platforms, the Danfoss inverter and the ABB inverter. ABB is the one we are currently using as the go-to stock item when we're talking about the inverter. That is the one that comes as a standard on our rack platforms. When you look at this compressor just to the left of the two inverters, that is LSPM compressor with the CO2 technology. That is cylinder unloading technology on this one.
And that one you said can go down to like 10% capacity?
Yes,
That's
there's
awesome.
a bit difference on how we use it, but the cool thing is it is delivered without an inverter, so it only always run 50 hertz. But so that means as a main compressor, it would be slightly bigger, but it can go down to, as you mentioned, 10% of a compressor capacity.
Yeah.
That is pretty awesome.
Yeah.
We actually have some examples where we're putting this one on afterwards or delivered with this rack. Then you can have this MT1 compressor running for 1 week, 2 week at a time without a single stop. That
Yeah.
really has something to say with the part load, because that is the thing we are dealing with. That is some of the things creating a challenge sometimes. I think some of the problems and some of these things I will actually also use time on when we are performing the training. We always deliver our racks tested, IO tested, set up from the factory,
Okay.
always. All valves or each wire connected to our rack, that is walked through by an electrical tester who also program it to the customer's wish.
That's awesome.
Yeah, I think that is very cool. But when I perform this training here in this room, some of the things we spend a lot of time on is to try to explain or try to teach, not how the rack, how to start up the rack. We spend time on that, but I think we have some very good manuals that also explains that. But we spend time on how to optimize the installation, the rack energy optimization, especially because we know a lot of that is simply how it's designed from when it's delivered. A lot of the end users request more capacity than actually needed because they want to future proof it, you can say. And that gives us some challenges on the part load, sometimes at least.
Yeah.
And that is actually what I spend some of the times on here when we're talking about this, is how can you optimize the installation? How can you improve on this part load capacity, etc., 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 just to make sure that the rack is running as smooth and as energy optimized as possible. I love it.
Yeah. I
That
got a
is,
question here.
yeah.
The small hermetic compressor there up in the top right, is that for emergency cooling?
Oh, this one.
Yep.
Yes. This one is actually, yes, for emergency cooling. We have designed this emergency cooling unit, which is actually placed parallel to our parallel compressor. So it simply just circulates the refrigerant cycle around like in the normal system, out to the gas cooler, and then back to the receiver. So taking the gas out from top of the receiver, and it delivers back from its own high pressure valve that we have put parallel to the normal high pressure valve.
Awesome. And those are real important because I've done lots of trainings where technicians said that we don't have auxiliaries, but those units, also, and I don't know if you do the same, I haven't asked you this, you can use those as service. If you're ever pumping down the whole system, like you can turn on the auxiliary and run it so you keep that flash tank cold. Do you guys do that as well for your systems or no?
Not necessarily, but that depends. Because the thing is, everything has something to do with price, but our standard receivers today are all 80 bars. That was 1160 psi, correct?
Yeah.
Yes.
Yeah.
And we know that is a pretty high temperature when we go up there. If we choose it, a lot of the safety are put in with the 60 bar, which is slightly less, but we have the possibility to put in this switchover valve. So we actually have an 80 bars and a 60 bars safety valve on this system. Then when you perform service, you simply just switch it to 80 bar when you perform the pump down. That buys you a lot of time It's very, very rare when we are out and performing some kind of job that we see the pressure rises so much that one of the safety valves goes off. The biggest problem when we are performing service, that is to make sure that the client goods are kept in temperature. So you need to perform the service at a certain speed, but that is not because of the pressure anymore.
Yeah.
That we have designed us out of.
Yeah. So I know I had questions from technicians before, and because I share a lot of your videos,
Yeah.
and one of them was like, if a compressor does fail, say one of those bits on the lower one, what do you do with the discharge line? So sometimes the suction's in the back, so you can't pull it out of the back, but then you have the discharge line in the front. What is your procedure with that discharge line?
As always, we recommend that you leave enough room in front of the rack.
Hmm.
And here you can see this this line here, the discharge is actually bolted on like this one, so you
Hmm.
can loosen this. I don't remember the English word for the press fittings, cutting ring, if you know what I mean.
Hmm.
So it's actually possible to move this one, loosen it. Of course, you need to take the pressure off, but you can loosen it, turn it, and then you can remove the compressor.
So you pump down that whole header then, and then reduce the gas pressure in the whole header. So you shut down the rack. Would that be correct?
Yes, the
Nice.
balance is, and to be honest, Trevor, I will not put a time on because that depends on the system and how
Yeah,
experienced you are.
yeah.
But that is where the PID really comes in to strengthen this. You just need to perform a pump down, always full pump down, put the liquid to the receiver, then you know where it is, then you're in control of what will happen in your system. That is the best thing I will always recommend that. And then you simply just look at the PID and say, okay, I need to isolate the discharge line. And then you just simply find the valves you need to isolate here and close them and relieve the pressure so you have a slightly over pressure, something like that. And then you can loosen this pipe.
Yeah.
If you need to work a lot on the compressor, you can just tighten this pipe one more time when it's open. And to be honest, then you can start up your rack. Sometimes you have very big compressors or something like that, which take a lot more effort just to remove. And if you don't have that time, then maybe you have to close down your rack for 20 minutes or something like that. And that I think most of the rack can actually handle.
That's awesome. Yeah. So that's so important because I know you talk about this all the time about working on the system, pumping down the rack, and I talk to lots of technicians. They're like, Trevor, that just it doesn't happen out in the field, and I'm cut for time or I'm tough. I don't have that much timeline, but with this you do have time. Like you got to take the time and make the time with it because I like the way you put it is that you know where all the liquid is. If you pump it down into the flash tank receiver, you know where it's all at. And then now you can actually, after you do your adjustments, like you said, you tighten it back up, you can actually just start it back up, give yourself some time to remove that compressor, put it back, pump it back down again, and then put it back into place, that proper discharge pipe. I love that.
It's all about control, knowing where. The most important thing here is always to know where you have your liquid CO2. If by somehow something takes a longer time, then it will only be a little gas pressure that will actually leave from the LT line or something like that. And that you can handle afterwards because that is not a massive loss in a refrigerant or something like that. As long as you actually know where you have your liquid and that will be in your receiver after perform pump down, then you have nothing to worry about. Most installations, depending on the size, but like this cubic, believe me, it takes less than 10 minutes to perform a full pump down. So why don't do it?
Yeah.
Do it correctly. It's kind of funny when I started to perform these trainings, I had to, I was thinking they have to learn everything about what happens in the transcritical states, et cetera, et cetera, et cetera, just making sure they know everything within, it's only 2 days, but I wanted to share all of my knowledge at,
No,
at
that's
a
amazing.
very limited time. But I found out that the most important thing is to make them comfortable working with the rack. And just by making them comfortable, how do you read the PID? How do you actually find out how to isolate the receiver and making the full pump down so you can perform any kind of service? That is very, very strong and is something that when they go back, they can actually use it.
Yeah, no, and I think that's so important. It's just helping more these refrigeration professionals to be comfortable with CO2 and
Yeah,
comfortable in the systems, because you do need to have the fundamentals of refrigeration when you're getting into CO2. You have to understand the basics. You have to be strong in commercial refrigeration if you want to start working on CO2 really. And I always
yes.
recommend always going back to those basics and those fundamentals, and I love that. And that PID is included in that. I have another question here. Why not fit check valves on those discharge line in the headers? Because I've seen those, you see those a lot on the HFC racks. I'm assuming that's the question they were asking. So instead of having them pump it down and move the discharge header, why couldn't there be discharge check valves in there?
Discharge check valves. Where?
In that discharge line, I'm assuming that we were talking about when you have to
Oh,
replace the compressor.
that's a good question. I think no, it also has something to do with how do you actually want to design your rack. And one of the things is it is very, very, very important to keep it as simple as possible. When you look at this installation, I will try to see if I can follow it. We actually have the discharge line down here going into the oil separator. And if you look very closely, you can see it goes out here and follows the pipe up here. Up here, we have our safety valves. With all this system built up like this, you also keep it kind of simple at the same time. I hope that answers the question.
Yeah, they wrote in at the header connection. So maybe, David, I'll let you elaborate a little bit more. Why not fit check valves at the header connection? So go ahead.
Yeah, it's those check valves. I kind of misunderstood the question. It's also okay. I think I will try to answer that. Maybe it will be a critical answer, but I actually hope you bear with me. Two things. For me personally, you cannot never be 100% sure if the check valve is actually leaking. When you put on check valves, extra shut-off valves, you can put a bypass if you need to change the oil filter in the oil reservoir, etc., etc., etc. Everything you put on a rack just raises the price of it. And to be honest, how often do you need to close down a compressor and to change it? And when you do, in this case, in our rack, you can actually close down. In this, I think I would need to have it closed for maybe 20 minutes, maybe a half an hour, but not more. Then it would be up and running again because I can actually just move our pipes we have here from the discharge side of the compressor. I can just move those pipes and tighten them again, and then you can start up the rack again, even
Yeah,
though you haven't changed the compressor.
yeah, I get you. Thanks for the question.
Just
Yeah,
loosen here.
yeah. But once again, make sure the pressure's out, it's pumped down, and the pressure's out. You do not loosen that stuff with the when the system is up and running.
Actually, I hear a lot of people talking about this with the time and everything, and I do understand that the time is always a question. But with a little experience, I don't believe the time is a big problem that makes you need to put on a lot of extra things just to buy you minutes. Because that is actually what you're doing. You're just buying minute by adding a check valve on this one.
Yeah, and it's similar to no different than HFC racks. Like you have an experienced technician who's worked on it before. Their procedures are going to be a lot quicker than someone that's not as confident. And so it's no different with CO2, because work with guys that are working on CO2 day in, day out, and they don't run into any problems like that. They can work on CO2 systems quicker than HFC systems now, they tell me. It's just
Yeah.
about that experience and the time that they put in, right? So, and it's confidence,
And
a lot of that stuff, and it's experience.
if you ask a technician to design a CO2 rack or all other kind of racks, then I think the price for a rack would be twice as much because you cannot put too few valves, etc., on the system just to make it easy when you perform service. And if you actually ask one of the sales guys, how would you design one of these racks? Then I think we would have
No, nothing on
less than
it.
nothing on it, no valves,
Yeah.
nothing at all. So we're just trying to aim something in the middle that makes it easy to perform service on the rack, but also not adds too much to the total cost of the installation. After all, we simply need to keep it as simple as possible. In that way, we get out to a much broader audience.
Yeah. No, no, exactly. We do have another question. Like, can we dive in a little bit more into safety?
Yeah.
So, on these CO2 systems, there's just not only one safety, there's many safeties. So, it's not only that you got the pressure relief safeties, but then you got high pressure safeties, you got controller safeties to shut down the system. So, can you just expand a little bit on how many layers of safety you would have on your CO2 systems?
Yeah, I will actually start at the top. This I have to do in bars when we talk about pressure. Then you can say what it is. The top safety here is of course our pressure relief valves (PRVs). That is mandatory to put in, and when we have these PRVs on, they will always be in contact with entire discharge line, so you cannot cut off the pressure. That is what you see here. There are no ball valves or something in between here. If just a quick one, it is possible to have a doable with a three-way valve to switch over valve to switch in between these two when you want to perform service. After that, we need a mechanical pressure switch to cut off. In this case, that is the one we have actually mounted here. You can see on the rack. That is always, in our case, placed in the common discharge line. That is a PS times 0.9. So in this case, with a 120 bar system, that would cut off at 108 bars.
And so 120 bars is 1740, and then 108 is a 1566 psi. So
When we look at it, you can see here we in our controller platforms, and that actually goes to all our controller platforms with the minor differences because they're designed differently, of course. But as a rule of thumb, around with the 120 bar system, just slightly under the mechanical cutout, 105 bars in this case, you are actually electronically cutting out all the compressors.
and so this is the big thing that I always tell like people, like if your pressure is getting really high, and it's near the pressure relief, like what do you got to do? You just shut off, get some compressors to shut off. That's what the controller is going to do, right? So you hit this 105 bar or 1522 psi. The controller is going to say our pressure is too high. Let's just start shutting off compressors because we're compressing. We are making that pressure go higher.
Exactly, exactly. But before we cut out electronically with the controller, we actually start to take out the capacity just to try to keep the pressure down to avoid this electronically cut out. This is our common discharge safety. But actually, we also have on our high pressure valve, which is we have to take some pressure drop into consideration. But when we look at the gas cooler side, which in an open system, a transcritical system, is a part of discharge line. You have the same pressure there. We have the possibility to start to open up the high pressure valve when the pressure gets, let's say, it gets close to where the the control will cut out the compressors. Slightly before there, we actually start to open up the high pressure valve more to relieve the pressure into the receiver. This keeps the system running.
Yeah. So that's
And it,
right there. We talked about four. That's four layers of protection right at that point, and I bet you there's even more. But
yeah, because we haven't even talked about the layer that goes to each compressor.
yeah. So you got the high pressure valve will open up more. You got the controller cutout, then you got the high pressure main line cutout, and then you got the PRV, which is your last line of
Yeah,
defense. So these systems are built very safely from what I see, and it goes with the other manufacturers too. Working with CO2, they're building
yeah,
them that you can work on them safely. And usually, what I've been seeing and hearing, and professionals been honest with me, they're like, Trevor, we caused that valve to relief by, shutting the wrong valve or turning off
Yeah,
the wrong breakers or shutting off the wrong components. And it's just, once again, it's like we just weren't experienced with it. So
that is usually how it is, and we also learn and learn to adapt it to different kind of temperatures and everything like that. And that was actually what the little story. Southern part of Italy last summer, I was down there, just a standard installation as you see, standard cubic as we have here. June, so 41 degrees ambient, that was equal to 43, 44 degrees Celsius out of the gas cooler.
wow, yeah,
100 bars, that is equal to, so that is very close to where we got off. That's actually equal to 40 degrees out of the
yep,
gas cooler. So was higher than that. Very hot outside, even though because we have this high pressure valve that could relieve the pressure into the receiver, we have a big store and everything was in temperature with a standard rack, 41 degrees ambient. Without, of course, it was calculated to it, but we didn't even had adiabatic cooling or stuff like that. We didn't even have a parallel compressor on it, and it was still running without any problem. No temperature raise in the cabinets. That is amazing, and
yeah,
that is how the system works today. Totally safe, no matter what the ambient temperature is.
yeah.
So,
Yeah,
yeah,
and I love that because I know I talk to people in South Africa and I know like 10 or 11 years doing CO2, and same thing, the temperatures there are 40 Celsius or 110 Fahrenheit, and
yeah,
the system still run fine, keeping temperature, not
exactly,
relieving. Is it higher pressure?
exactly.
Yes. But when it's designed for that, and there's even more technologies that you guys are even coming out with developing, like you said there wasn't even adiabatic, but the ejectors or flooded systems or what parallel
Yeah.
compression, all these other things that
Our
can be added, which you're saying is not even added to those ones. You know what I mean? So
No, but that is also where we are going when you look at this system. We are designing cooling refrigeration racks, but actually we also go the other way with heat pumps and with these climate system, everything like that. The basics, the fundamentals are the same. It just depends what part of the rack do you want to utilize, or do you want to utilize everything? That is the possibilities that we have here. And here it's also very important today with, with energy crisis, everything like that, to optimize on these installations, to optimize. And that is what we're actually doing with these low superheat, raising the suction pressure. That is energy optimization.
yeah, I
That
love
is
that. I want to thank you so much for taking the time to show all of us a little bit about your training center, showing us a little bit about the rack, sharing some knowledge and tips with us. How can people get a hold of you, get a hold of your trainings, and get involved?
well, we actually have at our homepage, advansor.com. You can go in and we have trainings you can sign up to. In these trainings, we have these online technical trainings where we have this new rollout here in 12 modules where we are actually talking a lot about the safeties. We're talking about how the gas cooler is actually working, etc., etc. And then we have these 2 days technical trainings where you can also sign up for these trainings at our homepage.
Yeah, I love that. Head to Advansor's website, advansor.com, go to trainings, get into the customer portal. You guys give out so much information you share with the world, with me, and I really appreciate. I want to thank you so much for taking the time to hang out with us
You're so welcome.
and sharing a little bit of knowledge.
That was a pleasure. That was a pleasure. It's what it's all about. Try to share the knowledge. It's just so important to get it out to the public. Yeah,
Awesome. Well, I want to thank you so much. I want to thank everyone for hanging out with the Refrigeration Mentor and Advansor just to learn a little bit more about CO2. Please share this with others because this is knowledge that we want to get out there, and more people are looking for this knowledge. Any way you can help, share a few things that was shared with you today. Talk to someone who's in CO2. Let them know because anytime you're sharing stuff, you're learning too. I want to thank everyone for hanging out with us, and we'll see you at the next CO2 Monday and Refrigeration Mentor podcast. See you, everyone.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.